Right, the organisers asked me to review this pineapple paper. As I said, I had nothing to do with the work and I hadn't seen the paper before. It was authored by Monica Sabatar, who many of you will know, and 3 academics from the University of Costa Rica. The title of the paper is Reduction of Post-Harvest Rotting with an Ethylene Absorbent, a Case Study with Pineapple. And it was a paper delivered at the 8th International Post-Harvest Symposium, which was in Spain in June 2016. It hasn't actually been published yet, but it will be published as the proceedings of the conference in Acta Horticulturae. But the scope of the paper was to determine if adding Bion will reduce peduncle rotting of Costa Rica pineapples stored under simulated export conditions. In the study they had 8 treatments. The first was untreated, the second was waxed before storage, the third was inoculated. Now the inoculation was they had penicillium spores which were blown into the atmosphere in the storage container throughout the storage period. So they're increasing the amount of fungal spores which cause peduncle rot. And the fourth treatment was wax plus inoculation. Now all these 4 treatments were stored with or without ethylene absorption, which gives us the 8 treatments. And ethylene absorption was ET8 50 units, which was sited near the room fans. Now the experimental details, they stored the fruit at 7.5 degrees for 25 days to simulate export, and then 3 days at 18 degrees to simulate a marketing process. They then assessed the fruit for rots and fruit quality after 25 days, and after 25 days, the storage plus 3 days at 18 degrees C. Now I've summarised the findings in the paper. Firstly, the effects of peduncle rot. There was no effect of wax or inoculation. The fact that there was no effect of inoculation was quite interesting, and I'll come back to that later. But the inclusion of ethylene absorption reduced peduncle rot. Now I collapsed the data they had, which was for the 8 treatments, into the 4 treatments that didn't have a Bion added and the 4 treatments that had a Bion tube. And you can see after 25 days, in other words when it came out of cold storage, there was hardly any rot, but 3 days later 30% of the control fruit showed peduncle rot, while only about 10% of the Bion showed peduncle rot. With fruit quality, there was no effect of any treatment on external colour or taste factors. But with fruit flesh firmness, while again there was no effect of wax or inoculation, ethylene absorption maintained a higher firmness. But again you can see that the fruit without the Bion and with the Bion absorbent, there was really no difference when it came out of cool storage, but after 3 days at 18 degrees, there was quite a big difference in firmness with the Bion treated produce much firmer. They also measured the effects of crown rot. Now crown rot is due to soil-borne pathogens, so it relates to what happens to the pineapples in the field, not what you do in post-harvest. And it's not caused by penicillium species. Now there was no effect of wax or Bion on crown rot, but interesting enough, inoculating with penicillium reduced crown rot. Again, I've shown the data here that the control is the 4 treatments without inoculation, and these are the 4 with inoculation. Again, when they came out of storage, there was hardly any crown rot, but after 3 days, almost all fruit without inoculation had crown rot, while half the fruit with inoculation had crown rot. Now, my conclusions from this sort of supports Darwin's competitive evolution theory, that somehow penicillium colonisation is able to inhibit the crown rot growth. In other words, the penicillium stopped the crown rot from germinating and preferentially would germinate themselves. Now the conclusions I draw from the paper that the use of the brown bion to reduce ethylene in export containers of Costa Rica pineapples would reduce the need to apply fungicides. It gives better attention to fruit texture. The benefits mainly accrue during the post-storage 3 days. Of course, there's no need to change the existing storage regime. You just sort of attach an ethylene absorbent tube in the container, and there's no perceived downside effect. I raised the caveat at the bottom. While they had a lot of crown rot, I don't know how serious crown rot is, and I presume it varies a lot between different farms, and it probably varies a lot between different seasons. Now in the paper they do a bit of speculation on how does potassium permanganate affect mould growth. Potassium permanganate is a strong oxidising agent and removes ethylene and a whole lot of other volatile organic compounds. Now the possibilities for how permanganate affects mould growth is firstly, reduced ethylene inhibits the senescence of the peduncle, so it maintains cellular integrity. The fungal spores can't grow because they need to be able to access the nutrients in the internal tissues to be able to germinate and grow. The second factor is that by removing ethylene, you remove the direct effect they or some other volatile organic compound has in promoting fungal growth. In other words, they suggested that maybe ethylene promotes fungal growth. I believe the first possibility is the mode of action, that ethylene inhibits senescence. And I believe this is supported by the data in the paper. Firstly, with the inoculated fruit, you're greatly increasing the spore load, but you're not getting any increase in mould growth. In other words, there's plenty of spores sitting on the surface, but they can't grow because the cellular integrity has been maintained. Secondly, cells obviously sustain their integrity during 3 days at 18 degrees C in normal air, so that the fruit in storage with the low ethylene have an advantage. Even though they haven't degraded, it hasn't advanced to the stage where it's about to collapse. So the rate controlling step, I believe, is the ability to penetrate the cells. Other research we've conducted, we've actually isolated moulds from various non-climacteric fruit, and we've not been able to demonstrate any direct effect of ethylene on these mould spores. We've also looked at some of these volatile organic compounds, and we found ethanol, acetaldehyde and some of the terpenes to actually inhibit mould growth. So removing them should actually enhance mould growth if there was any importance there. Now I believe these contentions are supported by observations we've had with strawberries. The fruit I described in the study earlier in the previous talk, the loss in quality was due to tissue degradation. So this is what the fruit looked like. You got these collapsed, damaged areas on the surface. There was no visible rot. But the bottom slide, the bottom figure, is fruit from our 1989 research study, and you can see that the loss in the control is due to rotting. Now in both studies we got the same reduction in ethylene, so you had the same effect of ethylene on tissue, maintaining tissue integrity. I believe the underlying cause of rotting is the tissue damage, which allows the spores to enter and germinate. Whether a rot appears depends on the spore load. Now in the current year, it's quite a dry year, and I suspect there's a low spore load in the field, which is why we don't see rotting in storage. I can't recall what 1989 was. That may have been a wet year where you had a high spore load in the field. But in the study, they measured ethylene. They took gas samples for ethylene analysis by gas chromatography, but they didn't detect ethylene in any sample. However, they said their limit of detection was 0.5 parts per million. Now, this highlights my view about the need for greater sensitivity. They needed sensitivity down to 0.01 parts per million. In other words, they needed sensitivity 50 times lower than what they had. They did actually prove that ethylene was being oxidised by testing the capacity of the capacitor permanganate to absorb ethylene, and they did this before and after storage, and they showed it was after storage than before. But obviously it's much better to be able to be measuring ethylene as you're going along. Okay, that's it for me, and thank you from the Big Pineapple in Australia. We like having fun resorts and that named after foods. We have the big banana, the big pineapple, the big prawn, and the big sheep. Okay, thank you.
Ron, can you hear me? No. Hello, Ron. Can you hear me?
Yes, okay.
Very good, excellent. I'm Alex von Stempel. You were due to speak in Berlin at Fruit Logistica, and of course you couldn't come, so we had to make do without you.
Sorry, there's too much echo.
Okay.
You're going to have to speak into just creating the echo between that and the mic.
I've got to speak into this.
Yeah.
Right. People are going to see my behind, but it doesn't really matter. I'm not important, so it's you. Can you hear me?
I can hear you, but you need to speak soft. It's echoing.
Well, so I was just wondering if you can accept any questions from the audience.
Sure, yeah.
Shall we try?
Yes?
If there are any questions, I've got one myself, but I first will ask the partners. Okay?
Yes?
The Mandarin study, was it waxed? Was the fruit previously waxed or was it without wax?
Could you hear that one?
Can you repeat the question?
Yeah, the question is whether the mandarins were waxed in the study.
Yes, they were waxed.
Okay. Is there another question? So I have a question. Perhaps it's a very stupid question, but well, try again. So
I'm sure not.
in your first presentation, when you were talking about the trucks shipping bananas from northern Australia to southern Australia over 3,000 kilometers, you also mentioned that in your introduction that there are other sources of ethylene rather than generated by the product itself, like exhaust gases from trucks. If I understand you correctly, basically to have this concept introduced but operated on a commercial basis, you need to ensure that either the trailer or the container is absolutely airtight, because otherwise you could have influx of ethylene from the surrounding from the surrounding area of the container. Is that clear, my question?
Yes, and I agree. And I agree with you. I mean, obviously, what I'm talking about are controlled laboratory trials, and one would need to go out and measure them under actual storage conditions. I mean, if
So there's some funny blips here. I don't know where they come from.
The thing is that when he talks, we have to mute ourselves, our microphone, that we don't have feedback. So it's like push to talk. When he talks, we push the letter.
Okay.
When we want to talk to him, we.
can you hear me now?
Yeah, so
Yeah, we hear you.
repeat that.
We hear you, Ron.
Can you hear?
Can you repeat? We have to mute every time you talk so that we don't have feedback. So please bear with us and repeat, please.
Okay. Yeah, I agree with you. I mean, obviously all the data that we presented were laboratory-based trials where we're controlling the conditions. We really want to go out and test under real field conditions. The other area you'd have to keep an eye on is also weight loss, where if you could see, one way to keep the ethylene down is to allow air to move across a load, and this is the way bananas used to be transported in Australia in rail vans, where air just moved through louvers across the fruit, and that was very effective.
Okay. No, I think he's dropped out.
No, okay.
Are you still there?
Yeah.
He's gone again.
No, I'm here.
Yeah, when you talk.
See, and this is what we were
When you talk to him, unmute it.
intending to do when in the study in Tasmania.
Then you mute again.
Right. Okay. I wonder whether there are any other questions from the audience.
I just wanted to ask him if he's done for bananas,
Oh, you need.
non-refrigerated transport. The example you're using, but instead of bananas, can you do the same thing with mangoes? Using unrefrigerated truck for transport of mangoes over a distance of 3,000 odd kilometers.
Can you repeat
You
it?
need to repeat those questions because
Basically, Dinesh wants to know whether it works also for the transportation of mangoes over 3,000 kilometers.
without refrigeration.
Without refrigeration, yes.
Oh, we haven't done mangoes.
And what would be the ambient temperature?
I can hear you.
Temperature.
With refrigeration.
No, ambient temperature. What
Without refrigeration.
What temperature? Sorry,
Come here, stop here.
Professor Wills, this is Dinesh here. I just wanted to know what ambient temperature are we talking about when we are moving fruits, like say Australian bananas over 3,000 kilometers in unrefrigerated trucks. And are these closed body trucks or open trucks?
Well, the current transport is
I think the technology is being stretched.
I can hear you.
Okay, should I repeat the
I-
question?
No, the question's okay.
Okay. So what do you think?
Well, I said we haven't studied mangoes because it's too hard for us to get mangoes very quickly after harvest. But bananas are all currently transported in refrigerated trucks, of course, which are sealed. What we're wanting to do is to get someone to transport them in normal trucks. And this is one of the things we're trying to do with the University of Tasmania. So if they can organise the transport of bananas on an open truck. So this is something we're working towards.
Right, thank you very much. Ron. I'm just wondering whether, I think we're coming to the end here. There will be probably loads of other questions based on your incredibly detailed presentation, of which I only understood a certain amount, but I'm sure that the partners here are understood exactly what you're saying. If they haven't, they will have to email you. Okay?
Sure.
No. I think that.
Okay.
I just wonder whether you can hear me now.
Yeah, you can hear you.
Yeah. So. Yes. Ron, I think.
No, that's the other way.
Let us speak.
Now, Ron, well, I think thank you very much. I'm confused now. I know, but it just doesn't work.
No, it
doesn't work. I just tapped the wrong key. So, well, thank you very much, Ron. And let's give another fantastic clap to what you've achieved. Thanks very much.